In this video, I'm going to show you how to write the explicit formula for a geometric sequence when you're given two terms that are not necessarily consecutive. They're not back-to-back terms. So you notice that in this example, I'm given the fifth term, a sub 5, and I'm given the second term, a sub 2. So when we're asked to write the explicit formula, it means that we have to fill in this formula, which is in my blue cloud, with the a sub 1, so that's my first term, and also the r, which is my common ratio. Now, I'm not given either of those two pieces of information, so I have to do some work to figure it out. I'm going to give you two different methods to doing this, so you can choose the one that makes most sense to you. So let's get into the first method. First thing we're going to do is use the information they gave us to write an equation. So I know that 768 is equal to a sub 1 times r to the 5 minus 1. All I did was substitute in to this formula. So a sub n is 768. A sub 1, I don't know what my first term is. I don't know what my common ratio is. But I know that the term I'm looking for, the n, is 5 because that's the piece of information that I'm working with. So I know that when I'm looking at the fifth term, that the value of that term is 768. So this is one equation I've built. However, in this equation, I have two different variables, and you know that you can't solve an equation with two different variables unless you have a second equation. So we're going to go ahead and build a second equation with the second piece of information that we are given. So we know that the second term is 12. So we're going to write that out as 12 equals a sub 1 times the common ratio raised to the 2 minus 1 power. Right? Again, substituting in that when the n is 2, then a sub n is 12. And now we're just going to simplify both of these a little bit. So the green equation is going to become 12 equals a sub 1 times r to the first power, which is just r. And the blue equation will become 768 equals a sub 1 times r to the fourth power. Now I have two different equations with the same variables, so I can solve them simultaneously. I notice that both of them have an a sub 1. So what I'm going to do is isolate a sub 1 in one of these equations. The green one obviously looks simpler. So I'm going to isolate the a sub 1 by dividing both sides of this equation by r. When I do that, I'm going to get a sub 1 is equal to 12 over r. Now that I know that a sub 1 is equivalent to 12 over r, I know that I can substitute 12 over r wherever I see an a sub 1 because they have the same value. So I'm going to go ahead and substitute into this blue equation, replacing a sub 1 with 12 over r. And now, if I remember my laws of exponents, I know that when I'm dividing with the same base, I can keep the base and subtract the exponent. So on the right side, this is going to become r to the third power. So I'm going to get 12r to the third power equals 768. Now I'm trying to solve for r, so I'm going to go ahead and divide by 12 on both sides. And that's going to give me 64 equals r to the third power. Now to get r by itself, I'm going to have to take the cube root of both sides. And the cube root of 64 is 4. So I have found my r, or my common ratio, is 4 in this sequence. Now, I still have to find the first term in this sequence because, again, coming back up to my explicit formula, there are two things we have to fill in, the common ratio and the first term. But we can very easily find the first term now because if I look right above my r, I have a sub 1 isolated in an equation. So I can replace my r now with 4. So I know that a sub 1 is equal to 12 over 4. So a sub 1 is 3. So the first term is 3, the common ratio is 4, and now I am able to write my formula a sub n equals 3 times 4 to the n minus 1. And now this formula here can be used to find any other term in this specific sequence. So that if I wanted the 10th term, I can just replace the n with 10 and find out what that term would be. So here's another approach to solving this problem, and it relies heavily on you understanding how the explicit formula itself works. So let's just take a second to go over that. Let's say, for example, I wanted to find the 7th term of this sequence. I would say a sub 7 is equal to a sub 1 times the common ratio raised to the 6th power, right? Because the exponent is going to be 7 minus 1, so it'll become 6. Now, why is this the case? Well, let's see. If we are going from the first term all the way to the seventh term, and you know that in a geometric sequence, I'm always multiplying by some common ratio that we call r. Take a look at how many times we multiplied by r to get from the first term to the seventh term. We multiplied 6 times. So that's why we got that, because we're doing 7, the term that we want to get to, minus 1, the term that we're starting at. And that tells us how many times we're actually multiplying by that common ratio. So now, even though I don't have the first term in this sequence, I can work with the ones I have and kind of rewrite this formula. So I can say that the fifth term is going to be equal to the second term multiplied by the common ratio raised to the 5 minus 2 power. Because look at how many times I would have to multiply by the common ratio to get from the second term to the fifth term. I would have to multiply 3 times. So that's where this exponent of 3 is going to come from for the common ratio. I'm multiplying by the common ratio 3 times, and I'm starting with the second term. So I can just replace, since I have this information, a sub 5 with 768. I can replace a sub 2 with 12. And now I have, if you remember, the same thing that I had with the first method. And now I can follow the same steps of dividing by 12 in order to isolate my variable. And I'll still get 64 equals r cubed. And at this point, I would take the cube root of both sides to again get that the common ratio is 4. Now with this method, I didn't do any work to isolate a sub 1. So from here, what we would do is, now that we have the common ratio, is you would pick either of the relationships that they gave you, the fifth term or the second term. I would suggest picking the second one since the numbers are a little bit easier to deal with. And we'll substitute into the formula. So again, we have a sub n equals a sub 1 times r to the n minus 1. So we'll replace a sub n with 12. We don't know what a sub 1 is. We can now replace r with 4 because we found out what the common ratio was. We're replacing n with 2 because we are dealing with the second term. So that's going to give us 2 minus 1, which gives us 1 as an exponent. So now I have 12 equals a sub 1 times 4. And when I divide by 4 on both sides, I'm going to get a sub 1 equals 3, or the first term equals 3, which is the same thing that we had before. And again, once you have these two pieces of information, you can go ahead and substitute them into the formula in order to write your explicit formula.